Gergo here from Gergo Print 3D. A quick but exciting update today for the popular Z-tilt adjustment method I showed you in a previous video for SOVO SV06 and SV06 Plus printers. I have now created a clipper macro that can make our job easier. It will measure the height difference between the left and right sides of the bed automatically and tell us how much to adjust the lead screw nut to align the Z motors perfectly. You can also mark these good lead screw positions for faster gantry leveling. Version 3 of the markers has these handy 5-minute markings to assist us with the manual adjustments. Please note, this update is only for those who already have Clipper on their SV06 or SV06 Plus. To learn how to update your printer with SOVO's Clipper screen, check out my previous video. I also created Z markers for the SV07 and SV07 Plus, link to the models in the description, but you don't need this macro for those. The 07 printers have more advanced 5-driver controllers that can do Z-tilt adjustment automatically all on their own. So, if you have a clipperized SV06 or SV06 Plus, I will show you where to find these new resources and how to install and use the new macro. If you find these tips useful, please give this video a thumbs up and let me know in the comments below. I upload 3D printing related videos 3-4 times a month. Subscribe to get notified. The link to the updated project is in the description. See? It now includes version 3 of the left and right motor caps. Make sure to print this version of the models. You will also need 2 little pointers, preferably printed in a contrasting color, and inserted in the grooves of the markers. Please refer to this earlier video for printing and detailed assembly instruction. I sliced the new models in my new favorite Orca slicer, and I'm utilizing Christian Vic's Clipper editions while printing. For more information about these, please watch my previous video. This time, I'm using SOVO Blue PLA for the motor caps. The new design has slightly rounded corners that print even more easily and will surely not curl up from the bed. No brims needed. As I'm adding these little red pointers from the previous iteration of the Z markers, you can see the new caps have more markings now to guide us with the lead screw adjustments. The pointers glide smoothly in the grooves of the markers. The whole fit is better too. They snugly wrap around the lead screw nuts without touching them. The SOVO Blue color matches so closely that they feel like they belong on the SV06 and SV06 Plus. Now that we have the new markers installed, we can set up the macro. You can find the file ztilt via probe clippermacro.zip in my CALTS 3D project. Extract the macro file ztilt via probes.cfg from this zip file. CALTS 3D don't let us upload CFG files just by themselves. I have to zip it. Then, in the web interface of the Clipper screen, we go to the machine page. If you need help connecting your computer to the printer over Wi-Fi, please watch this earlier video on setting up SOVO Clipper printers. With the machine page open, we can simply drag and drop the extracted macro file to the main directory, so it shows up in the same list as printer CFG. Again, we can hide backup files under the cogs menu to reduce clutter here. Finally, we double-click on printer CFG to edit it and add the line square brackets include ztilt via probe.cfg somewhere near the top, and make sure to use square brackets and the underscore character between the words, except between include and the name of the macro file. Once done, click Save and Restart, and we are done. If you want, you can set up the macro to be available on your dashboard in the web interface, but you will most likely use it from the Clipper screen directly. There, you will find it under Macros, which is the third button on the bottom of the screen. Since its name starts with the letter Z, it will usually be near the end of the list. Click to start it. The printer will heat the bed to 65 degrees Celsius. I'll show you how to change this default value, or you can just preheat the bed to any temperature before running the macro. Then, using the inductive probe, it will measure the distance from the bed on the left and on the right, and then display a message like this on the screen. Turn right knob counterclockwise 8 minutes. Following these instructions, I rotate the lead screw counterclockwise a little more than a full marking. The marks are 5 minutes apart, and the full circle is 60 minutes, just like on an analog clock. If we don't get it right exactly, it will tell us when we run the macro again. But I may have been lucky this time and got it right on the very first try. See how the final message tells us the difference between the two sides is only 1/100th of a millimeter? Perfect alignment. The macro will disable heating only at the very end of the leveling procedure. It will keep the bed heating between the measurements. It will unlock the motors between measurements so we can adjust the lead screws, but the motors will stay locked at the end to prevent them from drifting away from each other, so we can start printing right away with perfectly level gantry. Let me come clean. I said I was lucky. Actually, it wasn't luck. Notice how I simply turned the notch to where the red marker was pointing? That's what these markers are for. Once we level the gantry using this method, we can mark the positions of the left and right lead screw nuts with these little pointers. And next time we home the print head and find that the notches don't align with our markers, we can simply unlock the motors, this is an important step, and quickly rotate the lead screw nuts to match the pointers. This is way faster than redoing the leveling, and definitely faster and more accurate than the old top ramming or the various soup can methods. There are two settings we can adjust in the macro if we want. Setting the accuracy here to 0 will make the routine more strict. It will keep asking us to adjust until we get the two sides within 0.06 millimeters of each other. The default value of 1 is faster. It will accept the gantry as level when the difference is already below 0.12 millimeters. It depends on how precise or quick you want it to be. We can also change the target bed temperature. The print bed expands and warps differently at different temperatures. We want to level the gantry to match the bed's shape at the temperature we will print at. I usually print PLA at 65 degrees, so that's what the macro uses by default, but you can change it if you want. And if you preheat the bed to your preferred print temperature before running the macro, it will simply use that instead of the default. And that's all there is to it. I hope you like this. Please let YouTube know you do. I told you it was just a quick tip this time. Our gantry is level now, so we can go print 3D.